All right, so I'm obviously not on the coast. Originally we'd planned to meet up with Heather, the TA down there, and have a meeting, and that got canceled. So I didn't head down, but when Heather rescheduled her meeting, she said she's going to do it on Thursday. Is that right, Heather? You still going to do it on Thursday? Yeah. So it sounds like it'll either be 2 weeks from now or 3 weeks from now, right? Okay. So we'll do that. So today it's not a super intense day. Anyway, we're going to do the test review first, as I mentioned last week. So we'll go through. We'll talk about the test. I'll talk about what's on it. Anybody can ask questions. I picture this taking half an hour, 45 minutes, maybe a little bit longer. Who knows, depending on the questions. And then I have some material to present on just a new way to think about GIS operations. We talked about GIS operations, modeling them as a process diagram last week when we introduced Model Builder. Today we're going to talk about modeling spatial processes using something called SQL or SQL, but we'll talk about that after we do the test. So I have a test review up. If I have this up here, I'm really bad about closing tabs. I think this tab's been up here since last week, but it's still open, so I can go there. And so I actually have two things that I posted today, two items. They call them items on Blackboard. So the first I'm going to do is go over the VG Exam 1 review, right? And I'll go ahead and open this up, and I'll let you know that I basically designed the test and the review sheet at the same time. So pretty much everything that I can, unless something like filtered through my brain the wrong way, pretty much everything that is on the test is on the review sheet. So we'll talk about that. And obviously I don't have every single answer to every single question, but I'll try to even describe some of the questions as I go through the review sheet. And I am recording this. Hopefully it stays recorded, and you can come back and look at that later. So for those of you who haven't had one of my classes before, the test is mostly short answer. What I mean by that is that it's not multiple choice or true false for the most part. There are actually a few multiple choice questions, but they're the minority. So you don't need a Scantron. You're going to answer some short answer questions. Didn't bring a copy of the test, but there's 3 or 4 questions. I mean, sorry, not 3 or 4 questions, 3 or 4 pages of questions. I don't picture it taking as long as a normal class period to take the exam, and I'll give you a little more idea of some of the questions, style of some of the questions as we go along. There are a couple of, I guess, longer questions. They're not really writing questions. Some of them are, but there is one diagramming question. We'll talk about that at the end. All right, so let me just go through this review sheet, and I can provide some more details on the types of questions here. All right, now some of these are just going to be your normal short answer type of questions. So we've got a question here: how is the vector data model unique in GIS, different than raster? And so there, I expect you to know that that vector GIS data constitutes points, lines, and polygons that are all themselves fundamentally made up of points, which make lines, which lines can be used to build polygons. That's different than a raster data set that's an evenly spaced grid of numbers. So that should cover the questions on that sort of thing, if you understand that. Again, but that's kind of fundamental to the course. It's a pretty easy, straightforward question. Many of you who've taken the GIS course before you took this course probably understood that coming in, but there is a question on the test regarding that. So the next item says, what are the strengths of the vector data model? Here, specifically, you probably need to either provide an example or be able to interpret an example of a real world entity that would be better modeled by the vector data model rather than the raster data model. And we did talk about how you can really model anything in raster versus vector, but for the most part, what I'm trying to get at here is that discrete features, okay, kind of fit in the vector data model better than the raster data model. You can specify their exact locations, so they're not constrained to the center points of a grid, and they since they're features in the real world, they can be modeled directly as features in a database. Right? Now, going a little bit further on the vector, what is vector data, the vector data model, you should also be able to say that it's implemented in a GIS system as basically tabular information where the rows represent these features that we talked about. Okay, those represent things, entities in the real world. And the columns represent the attributes or the descriptions of the entities or the rows. So we've got rows, we've got columns, and you need to be able to know what each of them are. And that for the most part, these points, lines, and polygons can be treated or are treated like another column in the database. The spatial information is ultimately an attribute of the entity. Where is this located? And you know, we can choose to model things as points, lines, or polygons, even though their actual shape may be, well, probably is 3 dimensions. But this is a model of the real world, vector data model. And one of its weaknesses, or one of the realities of this model, is that we're looking at a planar, straight down view of the world, which is often how we view things as geographers. Okay, we did talk a little bit in that lecture as well about attribute measurement levels, and we've dealt with this since when we've created new fields. Oftentimes we'll create a new field and it'll ask us what data type. In reality, all the data types can be kind of boiled down into these measurement levels. But in practice, we have things like strings and floats and doubles. You don't really need to memorize all those. Those are essentially fitting into one of these categories. The data, the attributes are either nominal, meaning that they're the name of something, or a label. They're ordinal, meaning that there's order or a hierarchy to them. They can actually, any of these can actually be numbers. For example, we dealt a little bit with FIPS codes. FIPS codes are numbers. However, that's nominal data. Another one that we use more often is a zip code. Your zip code is just a label of where you live. Even though it's a number, you can't take your zip code and subtract it from another person's zip code and figure out the difference between your zip codes. I mean, you could, but that difference means absolutely nothing. You know, I live in 39475. Hattiesburg is in 39401. 0.06, and the difference between those two numbers doesn't mean anything. It's just those are two different labels. You know, you could argue that you know, zip codes slowly increase as you move west in the United States, but really there's not anything more than a general pattern to that trend. And so you can't really tell how much further west you are by an increase in number. It's essentially a label. So ordinal, it can also be numbers, but it could also be values. Essentially, we're talking about highs, mediums, lows, that sort of thing. If it's a real number, an attribute is stored as a real number, it's considered interval or ratio. And there's a subtle distinction between interval, which I didn't spell right, or maybe, yes, I did. Yeah, I'm horrible at spelling. Interval ratio, there's a subtle difference between those two, but you don't need to make that distinction for the test. So those are basically numbers. And the difference between these two is that one deals with an absolute zero value that makes sense. The other one doesn't. All right. We also introduced the concept of spatial autocorrelation at this point and gave a definition. You should be able to define spatial autocorrelation or recognize that that's what I'm talking about from the definition. So I have the definition right here on the study guide, and we expanded on it. That lecture, the lecture that was actually on spatial autocorrelation, we'll talk about that later, but the lab didn't exactly work out because all the computers don't have the proper licenses. So I won't test that as hard, but I do still have a few questions on it. But at least for this section, just know what spatial autocorrelation is, and it's basically boils down to the fact that locations near one another in space are more likely to be similar than data from locations that are remote from one another. We talked about a few problems in spatial analysis at that point, particularly the modifiable aerial unit problem and the ecological fallacy. We talked about a few other things like edge effects that I didn't choose to include on the test, but yeah, there's a question on the modifiable aerial unit problem and ecological fallacy, which are, maybe I should have included just like the definition for spatial autocorrelation, but the modifiable area unit problem is the problem that when we aggregate spatial data at different levels or arbitrary levels, oftentimes we'll see a different pattern or we'll get a different result from the analysis that we're doing when the data has been aggregated at a different level. Okay? And then the ecological fallacy is very, very related. The ecological fallacy basically says that that we can't make individual judgments about a group of about individuals within a group of aggregated data. Okay, we can make a summary statement about that group, but not in the I'll say this better. The example from the slides, if you go back and look at the slides, they'll be helpful here. The example from the slides was, let's say that we have two individuals. One of their incomes was very high, one income was very low. We aggregated their incomes and we came up with a mean value. We can't make a statement on either one of their individual incomes if all we have is the mean. We can only make a statement on their income as a whole. It seems pretty obvious, but and it does happen in places outside of spatial analysis, but it's good to bring it up here in a course where we're doing spatial analysis. All right, we talked about neighborhoods and adjacency at this point. You should recognize that there are different ways to define this, and that a GIS system is actually a powerful tool for defining adjacency however you want to define it. And for different analysis methods, there are different ways to define adjacency. Adjacency can be defined as only those areas that overlap. Adjacency can be defined as those areas that share a common boundary, or a variation of that is those areas that share a common boundary, including a single point. Or adjacency could be those entities that are within a certain distance of. And GIS systems have a lot of tools for assessing what a neighborhood or what adjacency means. I can say, find me all the polygons that are within 10 feet of me, or find me all the polygons that share a common boundary, or find me all the polygons that touch or overlap this particular entity. Okay. And in the raster world, we also have other ways to define neighborhood. We didn't talk about any of those in this course. It's for the raster GIS course. Another thing that we talked about was density estimation. Density estimation was specifically, we talked about kernel density estimation and basically counting up the number of neighbors for every feature and for every location, and coming up with an overall map or a heat map of the number or the count of observations. And sometimes you can use just a raw count, or sometimes you can weight it by some measure. So if your individual points represented homes, and you just wanted to calculate the density of homes for a neighborhood of 2 miles, you could have a moving window that went all over the map, calculated the neighborhood density in that region, and created a heat map. Or they could represent things like let's say, let's use more of a biophysical example. We went out and we found turtle nesting sites, and we actually were able to, I don't know, somehow discern how many turtles, how many nests, or not nests, how many eggs there were at every nest. We could weight the kernel density by the number of eggs at each nest, rather than just counting each one as one single point. Density estimation. It's related to neighborhood analysis. Okay. All right, we spent some time in the lab and a little bit in the lecture discussing the concept of a spatial join. And a spatial join, we'll actually revisit this concept today. Spatial join connects two data sets based on a spatial relationship. So there were in practice in ArcGIS, there were a number of different ways that we could create our spatial relationship, like within a distance of, or intersects, or within, and we could take one data set and copy the attributes or append the attributes of that data set onto another data set dependent on a spatial relationship. And sometimes that might involve a summary of that. For example, if there are multiple points within a single polygon, we would have to do something like, tell me the total number of points, or tell me the total number of one of the attribute columns. Oops. All right, the next one is overlay. Okay. Specifically, I'm really only going to talk about intersect and union on the test. The test only covers those two. Most of all overlay operations are really derivatives of intersect and union. So technically, what I'm trying to say is that, for example, you could do a symmetric difference by first doing a union and then a select. Okay. You could do in almost any of the operations by doing a few steps of a union and an intersect. So what you should know for the test is actually what I would do is go back and review the slides because you're going to have to enter on the test, you're going to have to enter how the information is changed, both the spatial information and the attribute information. So you'll have an example, you'll say, I'll say this is layer A, and I'll have a very simple sketch of a polygon, and this is layer B, and I'll have a very simple sketch of a polygon that overlaps it. I'm going to say, okay, these are the attributes for polygon A, these are the attributes for polygon B, and after you do the overlay, it might result in 3 different polygons. If we do a union, it would result in 3 different polygons, and you'll have to then specify the attributes that would result for those new 3 different polygons that were created. Okay, so you have to interpret drawings of, let's should say overlay operations, but overlay overlapping actually kind of goes together there. All right, and then for the lab that week, we did some capability suitability modeling, which we also talked about in the lecture, and we even mentioned and cited the book pretty well in that case. So we followed the book pretty well for the capability suitability modeling. And we talked about several different types of capability suitability models, which are basically overlay operations. Now there is some math that's included in these. And so here, what I want you to know is that when we do pass-fail screening, basically what we're doing is after we do the overlay operations and we're coming up with the final score, pass-fail screening makes it so that we're either yes, this is suitable, no, it's not suitable. And if it's not suitable in any of the layers, then it's not suitable. And so that's basically multiplication. If you go back and look at the slides for that week, pass-fail screening is just, the book actually called it binary something, and I'll take that on the test too if you use that term. Binary overlay is what it called it. And so we're basically taking each individual layer, and the attributes are either 1s or 0s, and when you multiply them through to come up with the final score, you get 1s only where it's an acceptable area in every single layer that was in the input. All right, ordinal combination is instead of multiplying them, you add them up. Okay, you add up each of the overlaid scores to get the final value. So that's, when I say math included, I'm just talking about pass-fail screening. You need to know that's multiplication. Ordinal combination is adding them up, and weighted linear combination is multiplying each by a weight and then adding them up. So that's the math is included on the last slide. I'm not going to make you like write a mathematical formula. Rather, you'll have to, I'll show an overlay. You have to come up with the final number, or on another question, it's the opposite where I'll say, what type of capability suitability modeling does this represent? And it might show layers being combined using pass-fail screening, where we get a bunch of 1s and 0s, and the result is either a 1 or a 0, true or false. All right, so that's capability suitability modeling. The next week we talked about a few different ways to categorize shapes. We talked about calculating the center of a shape. What is the center of a shape? There are 2 different ways that we talked about calculating the center of a shape, and these will be on the test. The mean center is the kind of like the well, it is the arithmetic mean of all the XY locations. So if it's a horseshoe-shaped polygon, the mean center of a horseshoe-shaped polygon, or even a ring-shaped polygon, is actually outside of the boundary of that polygon. Okay, it's not within the polygon. So to counteract that, there is another way to calculate the center of a polygon, and that is to make ever increasing smaller shapes within the polygon, and that's referred to as a skeleton. So if you go back and look at the slides, there will be a question on approximately where would the mean center of this shape be, approximately where would the skeleton of this shape be, something like that. All right, now you won't have to calculate any of the shape metrics, but there be a question relating to area to perimeter ratio or one of those, and you might have to pick out which one would have, which one would be the most compact shape. We talked a little bit about contact numbers, join counts, and forgot exactly what the question is on here. Maybe I'll go back in the break and check on that. But all right. So for regression on spatial, the next week we got into spatial regression. This is the week where the lab didn't go so well, and I didn't have you turn in a formal lab. But here are some of the concepts that I still want you to know for the test. Just like any data, we can do regression on two columns in a spatial database. Those two columns could represent things like income and education. Technically, that's not spatial. Okay, just because the entities represent counties, that's not really spatial data. There is a way where you can weight it to a geography, and we also didn't implement that, but that's called a geographically weighted regression, where instead of coming up with a regression equation for the entire map, it comes up with a regression equation that's local for the neighborhood. That's what geographic weighted regression does. So there's a different regression equation as you move across the map in X and Y space. So we did talk a little bit about spatial statistics. I would have liked to do a better lab on this, but there are two statistics that we talked about, Moran's I and Getty's OR G. Basically what you should know here is that these were measures of spatial autocorrelation, where spatial autocorrelation here was quantified, and we get a number, and that number ranges, and as we get on the positive side of 0, we have randomness, or no, randomness is in the middle. So on the positive side of 0, we get clustered. On the negative side of 0, we get dispersed, evenly spaced dispersed. And so these are measures of spatial autocorrelation. And so you need to be able to interpret positive and negative spatial autocorrelation on the test from an example and what it would mean, okay? Whether it's clustered, random, or dispersed. Okay. All right, then the next week we talked about spatial interpolation. So the goal of spatial interpolation is to come up with a surface. So it kind of sits on the boundary between vector and raster GIS. It's taking vector data, point data, and turning that into oftentimes raster data. It's not always raster data. There are vector models that can represent a surface. Okay, what are some of those? Well, the main one is using iso lines or contours. Okay. All right, we talked about a number of methods of spatial interpolation, and we divided those out into global methods and local methods. Most of the ones that we talked about were local methods. However, a trend surface would be considered a global method. And a trend surface is basically fitting a plane through the surface that's defined by your X and Y space, and then your Z space being the attribute, whether that's elevation or something, but the Z attribute or the Z data is your height, whether that height is actual height or some concept of height, like temperature isn't really height, but it's the Z attribute. And so if we were to make a global trend surface of temperature for the United States, and it was just a first order trend, in other words, a flat plane, it would get cooler as you traveled north, right? It'd probably also get cooler, a little bit cooler as you traveled west, okay? A lot of the geography, no, we don't have any geography graduate students in this class. Well, we have one, but you can go to AAG, right? Yeah, so a lot of the geography graduate students went to AAG last week out in San Francisco. It's cooler. Now, a global interpolator is most often inexact, meaning that it only follows the trend. It doesn't follow the points exactly. An exact interpolator will include the initial input points as the surface. So the surface will pass right through all of the points. Okay, that's an exact interpolator. Inexact means that the lines will not follow the surface will not necessarily follow the points. Okay. You can have a local interpolator that's inexact. That is possible, but most of them are. Like IDW is an exact interpolator. We talked about that. Okay. All right, which methods fall into which categories? Okay. So for example, you have to specify that on the test that IDW is an exact interpolator and it's a local interpolator. It only uses the nearest n number of points, okay? Whether you define that as only the points within 10 meters or only the point within some window or only the X closest number of points. All right. Generally how each method works, the only one that you actually have to calculate manually is the one that you did manually on the lab, and that's IDW, and it'll be even a more simple example than the one on the lab. Okay. But you will have to calculate IDW, so practice doing that. There's an example in the slides. Kriging. So kriging is the next thing that we talked about. We did breeze through kriging because we had to spill it into the second lecture. So you don't have to know like ordinary kriging, universal kriging, predictor kriging, indicator kriging. You don't have to know all of that, but you do need to know that kriging uses a combination of spatial autocorrelation and optionally a trend surface in order to make its predictions geostatistically. Maybe I should have put that in. So the advantage of kriging is that you also get an idea of the confidence of the prediction. Okay? That definitely should have been on the review sheet right there. Okay. All right, I'll go ahead and add that back in at the break or something. All right. Next thing is that if I put a modeled semivariogram, I want you to be able to interpret the semivariogram, particularly the range. What does the range mean on a semivariogram? The range is the distance at which there's any autocorrelation. Beyond the range, there's no autocorrelation. In other words, another way to say that is that points that are beyond the range distance away from each other are not related to each other. Okay, there's no correlation between those 2 points in terms of their values. right? And that was the last real week of new spatial analysis concepts. The week after that, which was just last week, we went over Model Builder, and I said that that there wouldn't be too much on the test, and there isn't, but there are a couple of questions here. One is that I want you to be able to diagram a simple process model as if it was going to go into the Model Builder based on a textual description of the problem. So in other words, if I give you a textual description of a simple GIS problem that involves an overlay and a buffer, I'll describe that in the question. I want you to be able to draw it out as if you were putting in a Model Builder. I don't care if you use squares for the inputs and circles for the operations, okay? But I will say in there, I'll just tell you which one to use. So just like Model Builder, we'll use circles for the data, and we'll use squares, well, little rounded squares, rectangles for the operations. But I'll put that on the test, okay? So if you're going to do an intersect between two layers, you'll have, layer 1, layer 2, intersect. We're not going to get into all the detail of Model Builder. In other words, you're not going to have to remember which ones to specify as parameters if you wanted to build a model out of it or anything like that. Just the general process. And then I haven't decided yet, but I was thinking of putting basically the opposite of that type of question, where I have a process model and I ask you to describe what's going on. That's the end of the review sheet. So if anybody has any, oh, and by the way, I forgot to mention this at the beginning, up here on this campus, GHY will be administering this test, and on the campus down there, Heather will be administering the test. So there's not a, there won't be, I won't be here for those tests. All right, so with that, are there any questions? If you do think of any questions, it'd be great to get them on the record, I guess is what I should say. And so if you think about them, don't just blur them out in class, but I'll ask one more time. Remind me to ask one more time if I didn't say after we go over the content that I want to go over. All right. So today we're gonna go over a PowerPoint, and then we're gonna try something. I would have really liked to be down on the coast today. I guess I still could have come down. But I wasn't able to test to make sure that everything that I'm going to do today would work down on the coast. So I hope that it does. If it doesn't, then we'll just follow along. Okay. All right. So the first thing I want to do is introduce the concept of what I want to talk about, and I'll actually be working through some problems as I go. All right. So I'm going to download this spatial database. I'm going to download this notes for the spatial database.doc as well. So in the past, when I've done this, when I've taught about this concept, what we're going to talk about today is using a real live relational database, and installing relational database software on every machine here is impractical, and it actually defeats the purpose of a relational database management system. The ideal way to do it is to install it on a single machine, and then everybody connect to that single machine. And then we can mess around with that data. However, whenever I do this, there's always problems connecting from the coast. And so what I did was set up a relational database model on the cloud. It's kind of cool we can do this. The free version is a little bit limited in terms of its speed. And so, although please follow along by all means if you want to. If you want to like join up, it may actually end up faster for everybody. But anyway, so working together. Okay, but before we get to all that, I want to ask this question here. We already kind of answered it in the review sheet. Okay, spatial data. Remember, spatial data is attribute information, particularly vector spatial data, is attribute information and spatial information, and it's in rows and columns already. Okay. All right. So the second question here is, what is a GIS? What makes a GIS a GIS? Anybody have any opinions on that? And there's not really any wrong answers. People talk about this a lot.
The first one, attribute information.
Okay. So just be able to display it, or does that go deeper then?
I guess that's what I thought. Yeah.
To be able to display spatial data. Okay. Anything else that a GIS?
And also be able to perform operations on that spatial data.
Yes, I believe that. Okay, so being able to perform spatial operations on spatial data is vital to a GIS. That's what makes a GIS a GIS. Some people, Keith Clark, he wrote one of the first textbooks on GIS. And in addition to what you said, display, and you said, which we call operations or analyzing spatial data. There are a few other things. One was manipulate, which you could really kind of throw into analyze, manipulate, but he was splitting a hair there and saying that manipulation is like more about the copying and changing the projection. Analyzing is what you were probably thinking of in terms of doing spatial operations. And then the fourth thing, though, is the display. There's the output. We already said display. Output. So be able to make pretty maps. Okay. And you could argue that that's not necessarily required for GIS, but it is helpful to be able to do your display. I mean, you do your pretty maps in the same software. And when I first started GIS, 20-something years ago, when I was an undergraduate, we exported our GIS data out of the command line system that we were using, which was called ArcInfo at the time, and we imported it into a precursor to to Adobe Illustrator called Macromedia Freehand. I don't know if anybody remembers. Anyway, and then you actually made your map inside of drawing software. You could make maps in ArcGIS, or what they called ArcInfo at the time, but it was really clunky, and they looked kind of like that map. And you all can't see it, but they all looked like it was just like outlines of stuff with like boring labels. Anyway, come a long way, but the analysis stuff is key. Okay, and I probably should have included a few more slides here, but a relational database is basically a system that allows us to store information in tables. Sometimes these tables are called relations, okay? But basically, data is stored in tables. Rows consist of rows of records, columns are fields. Sometimes we call the rows features, but in general database technology, those are referred to as records, okay? Just like in GIS, rows are usually identified by a unique key, okay? An object ID or an FID, and we can link the columns to other tables with similar columns, okay? The design of our columns and rows is referred to as a schema in database technology, okay? So when somebody says, I've got a data set, I've got two data sets from that represent population from two different governments, but the schema doesn't match. What they mean is the column data isn't the same. It's got different names, it's got different titles, different data types. And so it's hard to push together if it's got a different schema. It can be data that represents the same area, but it's a different schema. All right. So there's this big wide world out there of relational data. That's data that's organized like this. Okay. Today, in today's class, we're basically going to concentrate on. I said we will concentrate on these 4 tasks. Basically, relational data, relational systems do all 4 of these. We're going to concentrate on extracting and analyzing the data, not changing or inserting or deleting the data. And that's what we're going to focus on today. There actually is an entire course in this department that's devoted to this type of operation. But even if you don't take that course, many of you will encounter this type of data stored in this format when you go to a job. So it's important you understand that it's an entirely different way of looking at GIS. Other than the fact that it's still tables, the difference is in the way that it's analyzed. Okay, so the way that you analyze tabular data in a relational database is through a special language. It's called SQL. It stands for Structured Query Language. Okay, and we're going to be dealing with structured query. SQL is supposed to be, or SQL is supposed to be kind of a standard that works across a bunch of different databases. Because we've got anybody know of some brands of Access? Okay, so Access is kind of like a gateway relational database. It's not a true relational database. It's like the first step, but that's good.
From where PeopleSoft.
Yeah, I'm not sure what database is underlying PeopleSoft, but yeah, PeopleSoft has a big database under it. That's great. So what's that? Anyway, like Oracle is a big name in relational databases. Microsoft has one called SQL Server, okay, SQL Server, SQL Server. There's one called those are closed source commercial products. There are some open source products. One's called MySQL, MySQL, and another of the open source ones is called Postgres. And so the examples that I do today are from Postgres, and the reason why is that for some reason the people that were into open source GIS jumped into Postgres. That's where they put all of their efforts. And now I would argue that in terms of the analytical capabilities, Postgres is more advanced even than most of the commercial tools. Okay. Now they're not as fast and they're not as supported as well as some of the closed source tools, but the extension for Postgres that does GIS is called PostGIS. Okay. And you might say, why is it called PostGIS if it's just all we're doing is storing spatial information in a database? Isn't that what we're doing with like a file geodatabase? I mean, we can still look at spatial data in a file geodatabase, right? And it looks really similar. It's rows and columns of spatial data. So what makes a spatial database so different? Okay, well, I'm getting a little bit ahead of myself, but the answer is that in a traditional GIS system like ArcGIS, the spatial operations are done by the software. Okay, so you take your data and you feed it to the tools. You feed it to overlay, you feed it to extract, you feed it to select, you feed it to buffer. So buffer this, overlay that. You feed the data to the tool. Well, the model here is that you use SQL to ask the data questions. So the relational database contains all of the code to ask the questions. And in order to get to that point, we have to, we have to talk a little bit more about SQL so that you understand how to create it, how to use it, and that sort of thing. Okay? Okay, so just like in a file geodatabase or a shapefile, the columns have different data types. Okay? It's not really important that you understand all the different data types. We can have integers, we can have real numbers, we can have decimals, we can have booleans, in other words, true or false. All the columns can have all those different data types, just like they can in a regular ArcGIS data table. Okay. All right. Okay. In order to start formulating questions that we ask to the data, to the database itself, we need to understand a few SQL commands. Okay. So the one that we're going to focus on today is select. Okay, but I want you to know that there are other commands that you can give a database. But we're going to focus on select because select is the way that you extract, or basically the way that you get information out of the database. So it's the way you run the tools. So eventually when we get down to the GIS part, the select operation is the way you run an overlay or an intersect, or more generally, any type of spatial join. Okay. All right. There are tools for changing the data, for inserting information into the data, for deleting data. But we're not going to talk about all those today. We're going to talk about formulating questions for spatial data sets. Okay. The reason why we're focusing on select is because that's the way that most SQL work gets done, is using the select statement. The other thing about the select statement is you can't mess up your data using the select command. Select only helps you answer questions. It doesn't actually change any of your data, which is another advantage of thinking about data in this manner. So when you ask a question like today, we'll ask the question, what's the total length of the roads in Manhattan? Okay, if we wanted to ask our database that, we use the select command and it'll provide an answer. Well, if we did that in ArcGIS, let's think about how we would do it in ArcGIS. It may actually take the same amount of time or less time, but actually the buttons you'd have to press would be more. So let's say we had roads, right? We have all the roads for New York, and we have all the polygons that represent the 5 boroughs of Manhattan. Okay, we've got so it's the 5 boroughs of New York: Manhattan, Staten Island, those are the ones. And so we've got those 2 layers, one line layer and one polygon layer, and we want to find out what the total length is for the for just Manhattan. What do we need to do? Like what would somebody suggest a first step? Get all the locations of the roads? Right. Well, let's say that the roads, we have one layer that represents roads or lines, and we have one layer that represents these polygons. And when they already show up in the GIS, they already overlay each other. They already overlap with each other. But there's no way of knowing right off that the roads, the only way to tell which roads are in which borough is to actually we visually see, oh, that road is in Manhattan, or that road is in Staten Island. Yeah, you could do a union. You could do some sort of spatial join, but the point is you'd have to run a tool, right? You run a tool, and you get a new column on your attribute table. You can do either spatial join or union, they both work. You get a new column that appended the value of the borough onto the roads, right? And then you'd run a second tool that would basically summarize the column, that would summarize the length column. You might even have to calculate a new field called length, right? Calculate a new field, calculate all the lengths out like we did in some of the classes, okay? And then you would do a dissolve or a summary. Remember when we did the summary statistics on that result, and you do that by borough, okay? You do it by the newly appended borough column, and then that newly appended borough column, when you summarized it, the length by that column, you know, remember, okay, so I have our GIS up, have our catalog up. So if I went and did data management, generalization, dissolve, and I chose, for my dissolve field, I'd be choosing the borough, and for my statistics field, I'd be doing the sum of the length. And I'd run that, and then I get my answer. Okay, I sort it, find Manhattan, and right next to Manhattan there would be the length of all the city streets in Manhattan, right? Okay, so I would create 2 or maybe 3 sets of data in between. Each time I ran it, I created a new data set. Well, that's not how spatial SQL works, or that's not how SQL works. I would ask the question, it would run, and it would create a virtual table and hand me back that virtual table. And I would have that information, and it would run as a single command. If I wanted to save it out, I could. Okay, but it's just a simple transaction. Okay, let's talk a little bit more about how we can do this. Okay, so if you can imagine doing all of that in a single statement, it could get pretty complicated. That's one of the weaknesses. So one of the strengths is that we just ask a question, we get an answer, and that answer doesn't create a bunch of data sets on the fly, and it also, we don't have to press so many buttons, we just have to send one SQL statement. Disadvantage is that sometimes these SQL statements can be almost incomprehensible, especially for a very complex spatial problem. I've got to say, my head literally exploded when I was, my head never literally exploded. All right. So anyway, how do we form SQL statements? Because they're going to be the basis for our questions that we want answers to. The way that they start is with the word select. So then you say select, and you specify the name of the columns that you want. You can say star if you want all the columns. Okay. From, then you put the name of the table or tables that you want to deal with. Then that's actually all you need. So you can say select the name of the columns from the name of the table, and you could be done at that point. But there are a bunch of different operations that you can include. Okay, the next one is where. Where limits the rows that will be returned, or if we're dealing with features, it limits the features to only those features that match a criteria. Okay, now if this was just attributes in our table, we could say where we could say select name from the borough table where name equals Manhattan, and we only return Manhattan. Okay, or we could actually do something like, and if you don't understand the syntax yet, at this point, it's not a big deal. We could say this is spatial SQL. We could say select everything from, we could say, the streets and from the boroughs. So we're selecting everything from both of those tables, and we're saying where the boroughs table geometry intersects the streets table geometry. Then we're only going to get back the area that intersects those two areas. Okay? And I'll show an example of that, because that was just a kind of a pseudo SQL code. Okay. All right. So that's where. Group by, when we're doing like when we're trying to do something similar to a dissolve in SQL, then group by is the way to go. Group by takes your data and summarizes it by a category. That category could be borough, or if we're doing it by state. So think of times where you have data, but you want to summarize it by a different set of data. Use group by. Right? The rest of these are a little bit more obscure, and we're not going to get to them. Union and intersect here don't mean the same thing as they mean in GIS. These are for combining two tables. So if we had two tables that we were combining, we're saying only those records that appear in both tables would be intersect. All the records would be from both. So these are for combining. Except is similar. Okay, order by is another one that we should cover. It's not necessarily vital, but order by lets you sort it, sort the virtual table. Sometimes that's important. And then limit. Let's say that you know your result will return 1 million rows. And you just want to see if your query will work. You don't want to wait for 1 million rows to come back. You could say limit 5 or limit 10, and you only get 10 rows back. So it'll come back very fast. So it's good for testing. So limit is good for testing. Okay, we're going to look at a few simple queries here really quick. Okay, so we are going to talk about halving, but sorry, we're not going to talk about union and intersect and those other ones. Okay, so halving is similar to where I'm trying to think if there's any. Can't think off the top of my head whether there's any cases where you could use a where instead of a halving. In any case, this is the structure of a SQL command. Select a list of columns from the list of tables, what I already described, where a condition, group by an expression, halving, order by, or the sort order, and then limit by a number. So that's the recipe, the generic, I guess I wouldn't call it a recipe, but that's the generic formula. Okay? So your modifications to this formula are going to be in these triangles. What you would modify to make your operation would be in those. So halving is probably the least used out of these. Order by and limit are probably the second least used. Group by would be the third. Where would be after that, and select and from are all required. Or those are required. Select and from are required for a question. Well, okay, so there are special cases where from would even be optional, where you could just say, you know, select 5, and it would actually just return a row with 5 in it. You could do something like that. Okay. All right. So in order to ask a database questions, you do have to know the schema. You have to know the rows and columns in order to build a query. Okay? So you have to know what you want to do. You have to have that in your head. And then if you do want your data sorted, you should also be able to specify that beforehand. So if you have these things in your head, you can start to formulate your query. Okay. So sometimes you'll have to go look at the names of the columns, because if you don't know whether it's called name or name 10 or borough name or whatever, then you have to know which one you want. You have to know the actual name in order to make it into a query. So here are some examples of queries that are not spatial. Okay, so if we had a database that had a bunch of locations, but we were just accessing the attribute information, we could say something like select this is the unique identifier and the name from the location table where the state equals Kansas. KS is Kansas. Order by name. So what this would do is return a data set where we selected just those locations that were inside Kansas. It's not a spatial query, it's an attribute query. And we ordered it by name. Okay. Okay. What if we wanted to do two tables? In other words, we have two sets of information, and they have a column that represents the same thing. In this case, we can join them by the location ID. In other words, we can say, okay, we've got two columns of locations, and we want to put them into the same table. This is like doing an attribute join in our GIS. Okay? We've done that in this class, an attribute join. Okay? So the way that you would do that is say, select the names of your fields from, and you put both columns, both tables. This is the location table, this is the observer table. And you can join them by something that's equal. So that's how you do a join in a SQL query. Okay. Anything that will work in the where clause that will produce a Boolean value. So if you use any comparison numbers, we could say where state does not equal Kansas, and we get everything except for Kansas. We could say where state equals Kansas and where city equals Springfield. I don't know if there's a Springfield, Kansas, but there's a Springfield in almost every city. So we're just getting Springfield, Kansas if we use an and. Okay. There's a couple of syntax here. You don't need to memorize these or anything. There's plenty of help online, but just so you know, you can put strings together. You can actually find out. But you could write this differently. Like this says where FS is between 10 and 50, right? Another way to do that is to say where FS is greater than 10 and FS is less than 50. But there's shortcut syntax is what I'm trying to say. In operator works for like a set notation. And then sometimes you'll have null data. You can actually query on null data. Okay, let's skip this guy. Substrings. These are just formatting types of things, different tricks. Okay. All right. So moving on from select and from, go to group by. Okay. When you use a group function, group by function. When you say group by, you have to provide an aggregation for any field that you're not grouping by that you want to show up. In other words, when you say select, you say the sum of the population from the census data grouped by state. What that'll do is it will sum up the population by state. But if you didn't put some population, then it would give you an error. It would say, if you have a group by clause, you have to have an aggregation function to go along with it. Okay. And as soon as I start showing examples, I'll show this. In fact, maybe we can just bust that out here real quick. All right, so these first few examples, you don't have the software on your computers, but This is called PG Admin. Okay, and PG Admin is a free download. So if you wanted to do this later, you could on one of your computers. But what I did, or what I want, or what you can do, if you get PG Admin on your computer, is to connect using the connection information that I'm going to give you here. So if you go to Notes for Spatial Database, I'm giving you the connection information for my little database that I created. When I say little, they let you do up to 20 gigabytes for free. Okay, and this is on the Amazon cloud, and I set this up so you can access it. It's not sensitive data. You can access it from anywhere in the world. Okay, anybody can get in there. Anybody that actually has this information could go in, and technically, if you knew a lot about SQL, you could go in and delete it all using one of those other commands. But if you do that, I'll just put it back up, and it really won't be a point. There really won't be a point to it. So we're going to copy this instance into PG Admin. If you do have it on your computers, I'm not sure. I don't think you do, but if you do, you could follow along. But later I'll show you how to connect right into ArcGIS or QGIS. I don't know if QGIS is on those machines, but I know ArcGIS is, so you should be able to connect that way. So I'm going to call this Raver Amazon. Okay, the host is this big old path, and I set this database up last night, or not last night, a couple nights ago, literally in about less than 5 minutes. I set this database up. It's really easy to do. If I just Googled, because I knew they had this service, I Googled relational database service, Amazon setup PostGIS. And there was some guy that talked about doing it, and I followed his directions. Couple clicks. But if you want any help setting one up later, it'd be you know, a cool thing to do if you ever wanted to have some data that's accessible anywhere. You could do this. Okay, so the service here, actually leave that blank. Yeah, service leave blank. Postgres SD, the username is map awesome. This thing right here. I use that as a username sometimes, so I used it here. Password is GHY5051, which I often use as passwords for, not my bank account, but for geography department passwords, because it's the, anybody know why, Hattiesburg people? So it's the university box number for geography. So if you forget it, it's on the sheet, but 505, if you email something to Department of Geography, comma 5051, or mail, anyway, that's why I use that. Just like the door code up here is the door number from downstairs or something. It used to be 5051, the code on the door, but we changed it up every once in a while. Okay, so the database is GIS. That is under where do I put that? No, that doesn't go yet. So just leave all the rest of this blank. Don't update it. Say OK, and you'll see this when this pops up. You'll see this new Raver Amazon link, and now you can go into the GIS database. This is the only database that's in this data store that is that's spatial. Okay. So if you go down and you click on GIS and you hit SQL, at this point you'll be able to type in SQL statements. So I'll just do a few examples based on what we've talked about so far. So I need to know the schema, but I don't know it yet. So I'll just say select star from, I don't know if I'm spelling things right. let me see if I spell things right. Oh, it's NYC neighborhoods. I'll just copy this whole thing. You don't need to put the public .nyc neighborhoods unless you have a different unless it's ambiguous. We only have one New York City database or one New York City neighborhood. So now I get the result of my query down here. Okay, you see the columns. I have a column called GID. That's the ID. That's the unique ID field. Area, perimeter, New York City neighborhoods. That's just another number. Another number. This is the borough name. This is the name of the neighborhood. So like East Village is in Manhattan. The West Village is also in Manhattan. Okay. For those of you who aren't familiar. Okay. This was imported from a shapefile. So there's this what do we call that, artifact shape length column. But then there's this column called geometry, and there's just a bunch of gobbledygook numbers in there. But those numbers are binary numbers that represent the coordinates for each of those neighborhoods. Okay. All right. So I just did select star from New York City neighborhoods, but I could say where borough name equals, you use single quotes in SQL, Manhattan. So what's this going to do? Yes. So right now it would have done nothing. It would have said, it would have returned nothing. I don't think so. It just won't return any rows because nothing equals Manhattan. So 0 rows would be returned. But if I spelled it Manhattan, then I'll get only those that match that criteria. See how they only have Manhattan? So if I spelled borough name wrong, like if I spelled it out, now it's going to say a different error. Borough name doesn't exist. That column doesn't exist. That's why you need to know the schema before you attempt to do some queries. So it comes back pretty quick, right? So I could say, we'll get into I could buffer all of the geometries right here. Or I could say select ST buffer geometry 100. You won't be able to see the result here, but what it's doing now is it's buffering all. I didn't return all the columns. I only returned the geometry column, and it's buffered. But you can't see it because this interface isn't designed to see that. But this is a special spatial operation that I can do. All right, so let's do, instead of showing that one, let's show one that actually makes sense. So let's still show everything, and we could say here we could say group by borough name. We can run that guy. Oops. So select star from New York City neighborhoods where borough name equals to Manhattan, group by borough name. How many records am I going to get back when I do this? Yes, exactly. Okay, so this is exactly what I said would happen. I forgot about it. It's saying if you have a group by clause, you have to aggregate any field that you return. And since I'm returning all the fields, it gives me an error. So I have to group, I have to aggregate. I can do something like count. I can count the borough name. So now it's just going to give me, it says that there are 28 neighborhoods, basically, is the way you interpret that. 28 neighborhoods in Manhattan. Okay. Or I can't spell any of them. 23 neighborhoods in Brooklyn. 30 neighborhoods in Queens, and so on. Okay. Now, just so you're clear, we're not doing anything spatial at this point. Okay. This is just calculating out the based on two attributes, the borough name and the neighborhood name. Okay, so I'm going to go back to this guy real quick. And so I can do the max, the min, the sum. If we had population, we could do the sum of the population. There is some population, but it's in another data set, so I'd have to do a spatial query to get it. All right, we talked about group by. We didn't talk about order by, but that's pretty straightforward. Let me change this star from neighborhoods where. I'm going to change where. I'm going to take my where out totally. It's not required. And say order by. Order by borough name. So now, oops, select 8. I'm at star. So now I've sorted on this borough name. So I've got all of the records, all the neighborhoods. But I get all of Brooklyn's first, then Manhattan's, then Queens, and Staten Island, and then the Bronx. They're just sorted, and they're sorted alphabetically. And we didn't even get into this point, but there is a way to say I want them alphabetically descending, or I want them alphabetically ascending. There's all sorts of things that you can incorporate into spatial. Into SQL. Okay. All right. Okay, you saw that I did some of the I did a spatial operation. There are all sorts of spatial operations. Some of them do things like calculating the area. We talked about how to do this in GIS, right? We already did this, but we could say select star from neighborhood. Instead, we could say select our geometry column is just called geom. So we could say select ST area as area from the neighborhoods, order by borough name. So this is still just each neighborhood. We could say name. So now we're going to get the name of the neighborhood and the area of that neighborhood. And this is different than having a column called area. This is calculating that on the fly for each neighborhood. You can do the length, you can do whatever. We can actually nest these things. Like if I said, here's the area, we could say ST area, ST buffer, geom 100. What do you suppose this is doing? So this is calculating the area of this geometry. This is doing two different operations on geom. So what's it doing first, you suppose? It buffers the geometry by 100. So it's going out 100. Then it's calculating the area. So it's just calculating a little bit larger area. So now if we run this, it's function ST buffer geometry. Oh, I put an extra parenthesis in there. That's my bad. There we go. So now you see that the area, this is the raw area, this is the area of that neighborhood with 100, I think the units are meters, with a 100-meter buffer around it. So you can see all these are larger because they're larger. Okay. We could nest it even further. So now what we've done is we've gotten the centroid. This is the true centroid, so it's not the skeleton. The centroid of the geometry, we buffered by 100. and we buffer by 100, and then we calculate the area. So why are they all the same now? Yeah, the buffers are all 100, and they're all buffering what? What do you think the result of ST centroid is? A point, exactly. And so if we take a bunch of points and we buffer them all by 100, even though they're in different locations, they still all have the same area. Okay. All right. So what's the center of this? It's the center of Coney Island, the center of Sunset Park. It's the center of the neighborhood, not the center of the. Yeah. All right. Okay. So now, let's see. We can do all sorts of things. We can do spatial joins. We can do spatial joins. Remember that a join is what you need for a join is a Boolean relationship, a true or false between two data sets. So you say where this field equals that field, usually, if it's a field-based join. Well, if it's a spatial join, you can use one of these keywords. By the way, all of the spatial operations start with ST underscore. Didn't mention that. Okay, so ST intersects will join anytime they touch each other. It'll join. It'll create a new or to create a row with all the data appended that you want to have appended. So you've got intersects, contains, within. How do you suppose within is different than intersect? ST within. How do you suppose?
So does intersect include areas that are outside but then have a column from where they're together, and within will only include together?
So within, yes, it has to be completely inside of it. Contains means that it, so these are basically opposites of each other. Contains and within. All right, touches means they only have to share a common boundary. Crosses, if they're lines, crosses works. Within, D within is within a distance of. Okay, so these are not the only ones that have built, but you can see that there's a whole GIS inside of the database. That's why the name of the spatial extension is post-GIS. You can ask almost any spatial question that you can with the traditional tool-based system that you can with this. So spatial joins, this drives home the point. A traditional join is done like this, where you say, okay, select this column and this column from these two data tables where these two columns equal each other. In other words, if they have the same value, that's where you do the join. Spatial join, almost the exact same syntax. Select A dot var1, B dot var2 from AB, that's the same, except for now you say where ST intersects. In other words, where these two columns, these two geometries are equal to each other. And sometimes, so in ArcGIS, the geometry column is always called what? It never changes. What's the geometry column called or the point line or polygon column? Remember? If we right-click, open the attribute table, the first column is almost, that one does change. First column is almost always called OID or object ID or FID. The second column is always called shape. That's the name of it. So a lot of the times, if your data has been imported from ArcGIS, this column will be called shape. The other thing about spatial databases, though, is that this column can have any name you want. You have to know what it is. I've called it geom in this data, but it could be called shape, could be called geometry. You can actually have multiple geometry columns for every feature. You could have geometry column at one time and geometry column at another time, or you could have the point representation and a polygon representation, or or you can even mix geometries in the same column. ArcGIS won't let you import it if you do that, but you can actually do it. All right, here's a few examples. So here is a more complex example that is select the sum of the length of the geometry column divided by 1,000. Remember, it's in meters. So when I divide it by 1,000, what am I doing? What's meters divided by 1,000? Kilometers. Yep. From gis.public.nyc street. So what this is doing is getting the total length of all of the streets in New York. So that's the total length in kilometers of all the streets in New York. Spatial database query. All right. Here is grouping them by type. So now this is an attribute field, you know, whether it's a primary, a secondary, unclassified, or a footway that's paved, it's motorway, residential. So here's the length. So we've got 135 kilometers of primary, 276 kilometers of secondary, 71 kilometers of footways, 403 of motorways. These are basically categorical variables, and we've created some columns there. Okay. All right. Next is this one. This one's a little bit more complicated. Okay. Oh, by the way, SQL doesn't really care about spaces, white space, so you can press return wherever you want, and it'll still work. So if you think, in fact, some people like to do something like this. Right? So separating out the select, the from statement, the where statement, the group statement, each on a different line. But what we're saying here is select. Okay, now this notation is weird. B, you haven't seen that before yet. A, what does that mean? Well, if we want to do a join, sometimes it just helps me, rather than typing out this big thing each time, to assign what they call an alias to that table. So I'm assigning A to the streets and B to the neighborhoods. So whenever you see this, you're saying select B.name, that's the neighborhood name, then the length of the geometry, the sum of the length of geometry from both of these tables, where the roads intersect the neighborhoods. What that means, or the streets. The streets intersect the neighborhoods, and then group them by B.name, which is the neighborhood. So this returns every neighborhood and the total length of that neighborhood, total length of that the roads in that neighborhood in this column. So there's 123 kilometers of road in Glendale. There's 26 kilometers of road in Corona, and so on. Okay. All right. Okay, so the last step is doing this in ArcGIS or QGIS. I know we have QGIS up here. I'm not sure if we have it down on the coast. So I made this example in ArcGIS. So we open up ArcMap. And we can just hit cancel, get a blank page, and then go to the catalog window right here. Everybody can do this, by the way. So I mean, although you can do whatever you want. I know that not everybody had PG admin like I was just showing, but everybody has this. So go to the catalog window and go down to database connections. Okay. And then you hit add database connection. I just did this just right before class to make sure it worked on my computer. So I already have it up. So I'll just double click. Actually, it's not double click on it. It's right click on it. I'm going to right click on it and say connection properties. You're going to hit add database connection, and you're going to get a blank window that looks like this. Okay, where you fill in the information, maps. Don't try to type this in. Just copy and paste it from the Word document. Okay, map awesome, G501. Remember the G needs to be capitalized. And finally, remember on the drop down to choose GIS.
What's the password?
Capital G, then little EOG, GEOG, yeah, with the capital G, 5051. That's the password. All right. And when all that's done, hit OK. And it should be equally slow for everybody because in the past, it's, the computer's been right here in Hattiesburg, but now it's somewhere in some super secret Amazon location.
You said I need the internet.
You do. I would. You can enter that all in, but I would copy and paste it from the Word doc. Yeah, there's a Word doc called Spatial Database Notes, but that's a pretty long. I wouldn't want to copy it. I would copy and paste it. What's that? Did it work when you said hit OK? Did it report any errors? Oh. Did you all get an error?
I got there.
Did your stick fail to connect something? I'm on the coast. What'd y'all get? But it did let you choose GIS. Oh, you typed it in.
Yeah.
Did you type in this? 505. What's your error say?
The first time I did it, it came up could not connect, but now it actually won't work. GIS.
Remaining connection slots are reserved for non-replication. I wonder if my free connection only has like so many connections that it allows. Did anybody's work down on the coast, or did they all not work? What does your error say?
Specified server.
Okay. Let me try something. I'm wondering if my free connection doesn't work here. If it doesn't, then we may just have to like all connect. Oh, it says 22 connections. And I think the red line is supposed to represent the maximum. So let me try something. What version of ArcGIS also are you guys using down there on the coast? I forgot. Is it 10.3? 10.2? Okay. Connect. Huh. It's allowing me to connect. Okay, I just disconnected. See if Michael, you try to connect real quick. Or somebody try to connect. Still got an error.
It won't let me connect to it. Is this something we have to do?
Yeah. Well, let's just watch for now. I'll figure out why it's not working on some computers, because it is working on some computers up here, not on others. So I will figure that out. It does. Oh, now I'm getting the same error. I'll bet you it is a. It is an error. Why don't like why don't a few of you? Well, maybe I can do this remotely, because now I can't connect. Okay. Was anybody able to connect recently? You just disconnected? Okay. So yeah, it looks like, why don't we just follow along, or a few of you that are connected can keep going, but it looks like there's a limit on the number of connections with my free thing. Another option is I could just, if anybody wants to, I can point you to how you do this yourself, because it's pretty easy to set up, like I said. But what we'll do is I'll follow the rest of this through myself. Then we'll take a 10-minute break, and then I'll come back with what I want you to do for the lab. And as long as we're not all doing the lab at the same time, I think we'll be able to do it. Just because I got the same error right there on my computer, so it looks like it's a number of connections thing. Anyway, because it is a free account. All right, so let me continue this through, and then we'll take a short break and come back. I got the write-up almost done in my lab. So what's happened here is I've loaded a number of data sets up into the spatial database. This spatial database is in the cloud. So when I drag New York neighborhoods over here onto the window, first of all, unlike a regular data set, it has to calculate the extent on the fly. So it calculates it on the fly and then shows it in the window. Okay? I'm not sure, I look at this and I'm like, what's this white area right here? This white area right here? I don't know why those neighborhoods didn't show up. They're not even in the shapefile. So for some reason, there were some neighborhoods that didn't show up. So it's not an error in the import process. It's these neighborhoods just weren't included in the data for some reason. I'm sure they're real neighborhoods, but I'm not sure why they're not in the data. It looks like there's even a few up here actually in this area. But these represent neighborhoods. We can drag the streets on. I'm not going to drag the streets on because it's a big data set. But I'll drag the subway stations on here real quick. So here's all the subway stations. Okay. Here's all the homicides. Homicides is not as big as streets, fortunately. Speaking of AAG, the first time I went to the American Association of American Geographers conference, was like 10 years ago in Philadelphia, right after I got hired here. I was in the subway and people started shooting guns at each other. It was scary. Like it was actually this was the scariest experience in my life, because you usually don't see people shooting. Maybe you guys do, I don't know. But I was walking. There was a subway line that went under the tracks. So I've been to like foreign countries and stuff, but that's the only time I've ever seen people pull guns on each other. It was in Philadelphia. I know New York and Philadelphia are different places, but we're talking about homicide, so that brought back. I went out and I walked the 15 blocks to my hotel, and I never got on the subway the rest of the time I was in Philadelphia. There were like policemen running down into the subway station as I was leaving. All right, so people like hiding under benches. But these are all the homicides. This is the subway stations. We've got census blocks, which is also another big data set. Okay, now this may look like it's just your typical GIS data set, okay? But it's not. It's backed up by the power of the post-GIS. So when we do GIS operations, we could do those GIS operations as tools, but we can also treat ArcGIS like it was just a client for viewing data and actually tell the database to do the GIS work. Okay? The advantage to that is we're separating the viewer from the GIS processing, so we could just load light viewers on everybody's computer. And then the centralized server actually does all the GIS groundwork. So we could get an awesome state-of-the-art server to do the GIS work, and we could just have little viewers. ArcGIS is not a little viewer; it's a big, thick program because it has a lot of programs in it. But what's the ultimate example of a light GIS viewer in today's world? Yeah, Google Maps or some web client. Okay, and so PostGIS actually serves as the backbone to, or something like it. Sometimes it's Oracle, which does a very similar thing. In fact, the syntax is really similar too. But it serves as the backbone for lots of these things rather than ArcGIS. Yes, ArcGIS does sell a server product, okay, but it's tool-based. And so you have to interact with it by saying, okay, run this tool, run this tool, run this tool. And PostGIS is SQL based, so you can say run this SQL, return the result. Doesn't create anything on the server permanently, and you can see it. So lots of times when you go to a website that uses spatial data and you ask it to perform some spatial operation like a buffer or intersect, it's actually running some spatial SQL in the background and returning that. All right, so before you were to get there in your GIS career, you might want to test spatial queries to see what they're doing. So that's what I'm going to do here, is to show you this other thing that I have in here. This is the one we just ran. This is one that's a little bit different, okay? Let me explain what this one is doing here. So we're saying select ST union. ST union is a little bit different than your union command that unions two layers. This is a aggregation function. So because we have a group by clause, we're basically joining, oh, sorry, I got a little bit ahead of myself, okay? We're joining all of the roads to all of the neighborhoods, okay? Every time a road and a neighborhood intersect, we get a new row in our database, okay? And the rows have both of the information. So every row where a polygon and a line match up, we have a column that represents the polygon that matched the line, okay? So how many roads are there in Manhattan? Are there 1, 2, 5,000? There's thousands, right? Okay. So when we say to join those two, we get every time we get a join, we get a lot of records, and we're amplifying the number of records. So we have a record where we have a polygon and a line, polygon and a line, polygon and a line. And what we want to do is collapse all of the polygons that represent this group by clause, which represent the name. So if you're in the same neighborhood, we're going to group you all of the polygons, which are really going to be the same exact polygon. And what ST union does is it collapses all those polygons and unions them. It creates the union of all those polygons into a single polygon. So what this is saying is select ST union A.geometry as geometry. So that's going to be our new geometry column. B.name is going to tell us which neighborhood it was. Then we're going to get the length. So this query says, I want to get the total length of all of the streets in every geometry, and I also want to see that geometry as a single geometry, not 1,000 geometries, because you have to aggregate all the 1,000 geometries into one, which is going to be the same one. So what we can do now with this query, I can copy this, Control C, and I can go into ArcGIS and I can say File, and I can go to Add Query Layer. And I don't have my I can't get to the edge here. Okay, I have a workaround to that. So if this wasn't being shown on my computer, I could get to the drop down. But since I dragged on this neighborhoods layer already, I can right click on it and say properties and go to source and say change query. Okay. Then I can just copy and paste my new query in there and it should work. It's not giving me, still not giving me all the options. There's a verify button over here. Usually I hit that first. Hopefully it works to just not verify it. I think it's called validate. So if you're working on your computer, there's a validate, there should be a validate button. Okay, now it's calculating the extent. It's taking a little while. Why is it taking a little while? Because it's doing the spatial join now on the fly. It's calculating the extent of those neighborhoods, but it has to collapse each neighborhood onto itself. Okay. So now this is my new data set. It looks the same as the old data set, but the difference is that if I right click, it's running really slow, probably because a couple of us are using it and because it's on the internet. If I right click and say open attribute table, I messed up. B is the neighborhoods, right? Okay. This should say, so look what I did. So you see this little green line? What does that say that are those points, lines, or polygons? Lines. And they're lines because I said A dot shape, A dot geometry. I actually tested this before class and I messed up and I forgot to fix that. So I need to make that say B dot geometry because right now it's opening just thousands and thousands. I told you that was a really, really big data set, right? And since we're all doing it, it's kind of locked up. Oh, there we go. Okay. So it just basically said, I'm just going to, maybe I'll just bail out on, oh, that's fine. Let me just bail out of ArcGIS here real quick and oh, okay, so it did open finally. Great. So I'm gonna go back in and say properties, and now I'm gonna put the right query in there, and it'll run a little faster. So right now I change query. So now it should say B.geometry. That was my mistake. So we finish this up. Yeah, you paste over it. Yeah, you cut and paste. So that query represents when you dragged and dropped it into ArcGIS, it basically made that query for you, which was just use all the table, all the columns, and yeah, just use all the columns and show me everything, all the rows. That's the default. All right, so this is going to take a little while, but now the difference is that this attribute table, as soon as it shows up here, will now show what? It'll show the neighborhoods, but it'll have the length of all of the streets associated with them. All right, maybe we'll, if this takes more than a few seconds. We'll just take a break right now. But the difference here, I'll show you in the, so here is this, and it says SG union B geometry. What we're doing here is getting a new column. We'll have the length in kilometers of all the streets in our attribute table. And this, here it is. Oh, that's still polyline, that's still the old one. This didn't take so long when I did this a few minutes ago. I think it's taking a long time because it's now being utilized more. Not a reflection on the Amazon cloud is pretty quick. We use it for other operations. Okay, it finally came through. Beggars can't be choosers. It's the free version.
I think there's a polygon.
Okay, good. So you just came through the polygon, great. And so you were able to connect finally.
Yeah.
Because somebody disconnected. And so you have oh, mine came through too. Polygon. This is the length of all the roads in this neighborhood. Okay. Right. And so I will. Well, here as we go up. If I close this, you could actually look at it, and it would be just the polygons for the just polygons for the neighborhoods. But now that I could symbolize on that attribute, I could show the ones that had a higher length versus the ones that had a lower length. Okay, on the way to our break, I'm going to modify the query so that now I'm going to group by b dot borough name. And I'm going to, instead of B name, I'm going to say B dot borough. So now what's happening is that instead of unioning all the shapes that are exactly the same, I'm unioning all of the polygons that represent any of the polygons that have the same borough name. Okay. I'm grouping by borough name. So now I'm going to get the total amount of streets in every borough instead of in every neighborhood, but I'm still going to get shapes that represent just the boroughs. So maybe, hopefully, this takes. We'll just get this when we come back in about 15 minutes. So 3:20, and I'll post the lab. But basically what we're going to do in the lab is I'll let you do this mostly by yourself, but what I want you to do is modify this query so that instead of getting the total length of all the streets, we get the total count of all the homicides in the neighborhoods and in each borough. So let's let that thing do its magic. Come back at 3:20 and we'll be all set. I'll just hit OK here. It's 2010 data.
Nope. Where is it? Yeah, I do that.
Wow, I'm trying to figure out.
Why?
I would say maybe I would leave off on tone therapy, like instead of the tone therapy. Maybe see it kind of for me. I actually. I think this is fine. I think the one sentence is readable. What? Oh my god, it's fine. Do just what you would say. I can offer you maybe tea and some cupcakes. One day. Not Friday. That's for sure. I will not be in a baking mood on Friday. I will be strictly, I'm going to be to celebrate the loss of my Quidditch team. No Quidditch, by the way, Kelsey. No Quidditch this Saturday. What? Yeah, thank you. Quidditch? What is Quidditch? Did you just ask that? Have you read or seen any Harry Potter?
Oh, yeah.
Yeah, it's that game. They're national sport
Right,
in the listening world. You also want the Quidditch team.
You can't fly.
It's just magic. You run. So it's kind of like what what's it called?
You gotta hold a stick because when you let it.
No, but it's like really hilarious. Like everything about it's good. It's like capture the flag mixed with yes, no, it's good. Everything's good about it. Tackle football mixed with capture the flag mixed with a bit of dodgeball and like water polo on land. It's a really good game. It's a really good game. You don't like nonsense? You don't like nonsense? It's okay, it's better than before. Thanks again, exclamation point. Thanks one of you. It's probably spelled differently. It's actually really funny because he picks up these names that are like really not the most common names in the US. Like Maria's gotta be the most common name in the US. I really don't. No way.
I've met way more Sarahs.
Oh my gosh, Maria's like the number one. Like I mean, any Hispanic like or like any immigrant child who's named Maria.
No, I'm just saying. I'm saying Maria is common. That Sarah is more common.
I got over it a long time ago. There's gonna be more than Maria's. First or middle name. My least favorite Maria was a girl that was like Maria Pia. I thought it was the least attractive name ever. And then so she was like Pia as a nickname. I'm like, that sounds like me. Why do you want to go by that? That's really silly. No, I'm not really a fan. It's not letting me sign on, and I'm usually on board with him. Yeah. What's this fatal? Fatal. It sounds like I'm gonna die. Like this computer program is fatal. There may be financial flux. Watch out, this is fatal if you connect to this program. It's not gonna be good.
I had two spare parts. Besides the people that were usually out of the office, don't know. But I'd rather have actual efficient. If I could use
Oh, I took notes as fast as I was taking notes. Three pages of handwritten notes. First page, nice. My hands are tired. Second page, no. What's the definition of page? It's like a little you say
He's all the power that doesn't flag things to the south. You gotta want to try that. Ask yourself this: how many times in your remainder of this planet are you going to be the North Star? It's one of those things. It's one of those you got to walk in the mirror and it's really hard to start.
Oh my God, you've done it 55 times. So thanks, Rob.
I haven't figured out how to make those. Oh my God. It's that job working where you have flat tires, lost tires, and stuff.
Maybe just think about it. I think you have that. Maybe just better about that.
Yeah, so we're gonna wrap program cold.
It's that I use all the thoughts of study over there.
It is not. As of today's goal, when the remote geography was empty, the line is up.
Really wants to read their video. Probably, but it was just really funny. I was like, oh, Jeff.
All right. So it ran through, it looks like. If I close this, it basically it basically did the equivalent of a dissolve. You can see some of the internal boundaries didn't dissolve really well. There are ways to get around that, but some of these internal boundaries didn't really. What that means is they're probably digitized with a slight gap on this strip, and so it's an error in the data. One way to compensate for that would be to buffer everything by like 1 meter, and it would probably close all those gaps, and the union would not show those. But, these are the boroughs: Staten Island, Brooklyn, Queens, Manhattan Island, and the Bronx. This is probably part of Brooklyn. I'm pretty sure it's part of Brooklyn. Okay, so that's that. For the lab, this is what I want you to do, and we'll discuss how to do this. Here we go. If you refresh, I put the lab in there. Okay, so I've changed the statement so it's correct. The following SQL statement is used to get the length of all the roads in each neighborhood. You must modify it to gather the count of all the homicides in each neighborhood. So modify this statement. Which part do you think right off? No big deal. Yeah, I'm not worried. Computer's really old anyway.
Yeah, it's only on the wire.
So which part of this do you think that we need to modify? Everybody on the coaster here, what part obviously needs to be modified? We're changing from streets to homicides.
Streets.
Right, so this could just be changed. I think it's called New York City _ streets or homicides. It might just be called homicides. We need to change that for sure. All right. Anything else that we need to change? Are we getting the length of the geometry anymore? Yeah, and it doesn't really matter which field you count. You can leave it as you can leave it as a.geometry if you want, because points are points. So homicide points are still points. So you change this to count. Do we need to divide it by 1,000 anymore? No. So you just basically need to modify this right here, so that it would change. You no longer need sum, you need to use something else. You no longer need st.length. You still need the name of a field inside of this sum, but you won't be sum anymore, it'll say count. So change that up, and it will give you that. I suggest that you kind of Unlike a normal lab, I suggest you kind of stagger this. So you could do this lab at home if you downloaded or you could use ArcGIS. If you downloaded pgadmin, just Google search pgadmin, it's free download. And you could connect the way I connected in the lab, or you could use the lab computers, or you could use your version of ArcGIS. But in any case, I suggest you kind of stagger it because it seems like we're bogging it down. So unless you want to sit here and wait for it to run every time, it might just be best to have some people do it now and some people do it later. But in any case, that's what you need to do. Which neighborhood had the lowest number of homicides? Which had the largest? So you open up the attribute table. You could sort the attribute table, but another thing is you have to answer this question regardless of if you sort. What SQL modifying statement will help you find that information, the highest and lowest, easier? Okay, well, go ahead and answer that by acclamation if you want to. Anybody have an idea there? Okay, we could get the max and the min. We could use max and min here, but that would be the max for a particular column. Here, we're just trying to sort the table and find the highest and the lowest. I'm just saying, how do you sort the table in your SQL statement? Maybe it's a better way to say that. What are the SQL commands that we learned about today?
Order by?
Exactly. So we can do an order by. Modify your statement to include only those neighborhoods that should say in Manhattan, turn in that query. What do you need to change it to get only those in Manhattan? What type of statement do you need? Yes, it's a where statement. We already have a where statement. So the way that you do multiple where statements is by appending an and on. So you say where st intersects this and then you would add your extra line. And remember that like we've shown before, SQL uses the single quotes for a string. So you'd say, and the name of the field is borough name. So where borough name equals Manhattan. Turn in that query. How many homicides in Morningside Heights? So this is real. You could really answer this up here at the same time. But Morningside Heights is a neighborhood. Okay. Anybody know where Morningside Heights is? So Central Park is a central feature in New York. I don't know if you want to try to find it, like you want to try to identify, or you could just look at the attribute table. Central Park is a big central park here on Manhattan Island, and right next to Central Park, on the west side of Central Park, it's called the West Side. The Upper West Side is the area that's more upriver. Directly north of the Upper West Side, the next neighborhood north is Morningside Heights. So it's about right here. Press it. So like Columbia University in the city of New York is in Morningside Heights. All right. So I would suggest not identifying it, but if you want to try to poke around, you can. Modify your statement to group by borough name rather than name. Okay. You can do that because this will be on the video here. I already did it with that's what I did with this one. So if I go into here and I look at the change query, this query that I've modified, which you can't see really well, I'll copy it out of here and I'll put it right here for now. Okay, this one modifies the streets by borough name. I need you to modify the homicides by borough name and tell me which borough had the most homicides. Okay? All right. Finally, you have to answer this question, but you don't have to write up a query for it, okay? Because it's a complex question, and it would involve basically two joins. So you don't have to write up the query unless you really want to accept the challenge, But if I wanted to find out the murder rate in each borough, and I'm defining the murder rate here as homicides divided by population, which other data set would I need to join in? So you need to go look at the other data sets that I have loaded and figure out how you do that. Okay? And then finally, the location that I got this data was from a tutorial on PostGIS. So in full disclosure, I just wanted to tell you that. But also, if you wanted to learn more about spatial SQL, it's a great thing to learn about, and PostGIS, which is free. You know, you can, even without Amazon, you could load this onto your own computer and you could have a free GIS system, but you have to interact with it in SQL all the time instead of using tools, so it's a little bit of a disadvantage. But if you click this link, or copy and paste that link, into ArcGIS, into Chrome, here is a tutorial that you can walk through and learn. It has many other examples of cool queries that you can use. So you could jump in at number 6 about our data. So if you wanted to do this, you can jump in here about our data, and it will tell you. Now the tutorial is written assuming that you're going to use QGIS to visualize rather than ArcGIS to visualize. But you could still use ArcGIS, but you'd have to do some interpolation. We have QGIS on the machines up here. I'm not sure we have it down there, but it is another free download. And you could do all of the queries right in PGAdmin. The disadvantage is you couldn't see them. You wouldn't be able to look at the queries. But it uses the exact same data, and it tells you a lot more about the data sets, and has a whole big section on spatial joins. Okay, here's a rather complex join that's joining the neighborhoods to the subways and only returning one. Okay, we didn't even cover on. On is an alternative way to join rather than using where, so that you don't have to say where and, you can say on and then put your join condition and then say where and use for restrictive condition. All right, but it's a tutorial that gives you an option. You have a question?
What is the ST?
Okay, so Postgres SQL is the name of the database software. It's like Oracle, okay, but it's an open source version of the software. And PostGIS is actually an extension that's written in a programming language that lives inside of Postgres SQL. And PostGIS, what they did for convention purposes is all of the custom spatial functions that they created, they appended ST underscore to the front of them so that you know that they're spatial. It stands for spatial type underscore, and then the name of the function. One reason that they felt that they had to do that is that there is, as I mentioned before, there's already a function called union, there's already a function called intersect, and they don't do the same thing. And so ST union obviously does something different than regular old intersect, and ST union does something different. But there's there's no buffer command already, but they still appended ST buffer so that you know that that's spatial request. And then in addition to this tutorial, which is, I think, probably better, there is some just raw help for PostGIS help is out here. And you can go through here and look at, it literally has just a list of tons of commands as well as some background. Here's all the management functions, geometry constructors, accessors, editors, operators. Operators are the ones that you'd use most often to do analysis. You can find the area, the centroid, all sorts of, we talked about contains, but there's all sorts of functions. It's literally like pages and pages of functions that that are possible with PostGIS. So it is a complete GIS system. Some would argue almost complete without, it doesn't really have a display component, but it's just a totally different way of thinking about GIS, where you interact and you you do your analysis based on SQL commands rather than feeding your data into tools. All right, any other questions? This is not on the test. It's another reason why I did the review session beforehand. So we were going to do the test today, but it's easier to do it next week when I'll be out, or better to do it next week so we don't have to miss a week of the lecture, since we already missed a week earlier. All right. Any other questions?
The notes for spatial database on Blackboard now, is that corrected with a view geometry?
No, it's not, but I'll correct it.
Okay.
I'll correct that. I can do that right now after class. Unless y'all have any other questions. Yeah, I should have done that. The question here was, is this correct now? You know, even if I correct it, it won't correct your version if you've already downloaded it. But just so you know, this needs to say P. I will go correct that right now, re-upload it. No, it's B dot, because the name is the name of the neighborhood, and that's B. Good question, though. So yeah, that's correct. It's just the geometry that was messed up. Now it's not horrible to I mean, it would still be valid actually to write A.geom. The issue is that it's going to return the geometries from A. So instead of getting all the polygons pushed together, we get all the streets pushed together in one street, one large multi-polyline street, which isn't really what we want. We want to see we're not dissolving by this layer, we're dissolving by that layer. All right. All right, cool. So, yeah, I mean, you're all welcome to try it right now, but if it were me, I'd come back and do it another time, just because it seems like when we all access it at the same time, it runs a lot slower. And that's from my experience on how long it took me to do it here versus how long it was taking me in my office and yesterday when I was creating the lab. All right.
I have, when you're going over where RNA equals and how you begin, can I be interested? Or?
Oh, no, and spelled out.
Oh, okay.
A-N-E. Yep. Yeah, so that's when we're restricting it by just Manhattan.
Yeah.
Yeah.
I was like, yeah, I'm thinking about the word. Also, spaces, they don't care about spaces at all. So, like,
There can be like 5 spaces or 2 spaces, yeah. but this is an underscore, not a space.
Right.
So you can have spaces in between, but sorry, you can have spaces where they should have letters. You know, like it could put a space between inter and sex, but it could put a space after this parenthesis. I could put 10 spaces or 20 spaces, or even a character term.
Okay, but what about symbols like equal signs?
It shouldn't matter. White space shouldn't matter there. And it might even be easier to get the queries working in PG admin because they'll return faster than they will in ArcGIS. That's just a tip. All right, I'm gonna go change that. I'll be right back. If anybody has any other questions. Yeah.
Are you finished with class?
Yeah, there's no more presentation today. Yeah, we're running into a little bit early, looks like.
Thank
Yeah.
you.
Yes.
Right, you have to have and for and for, yeah, but I didn't put a comma after. I don't even comma. Oh, I'm not sure. What's your question? Yeah. Number 4. Yeah. I've known some people, I think I remember one time I was working with people in part one, instead of just wear something and something, they wanted wear something and wear something. Yeah, I put that and wear as well. Yeah, I did. Yes. And wear both. Okay, that should work. And there, just without the wear, then you're making. Oh, this is like, this is a page of that. I'll just do these. I would like my word to start with. So I keep getting an error that function or procedure does not exist. That's good. But I'm pretty sure I don't put in any functions. Yes. Oh, the argument. The vertical sweep of China's legs. Ooh, did it do it? Did it work? I don't know. No, there's no text. But it didn't give me a little message. I can word X to start too, and then I can Iris. You're sure?
are blah, 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 and things about, like, you know, for the IRS. They, like, if they call you, or message you, or something like the letters, like, IRS will pay a lot of money to sign for it, or they go, well, this means that, the IRS. No, I got out for your arrest. No. No, they will really take time. That's what happened, and you know, that's actually, I sent in mail that I was going to your next morning, like, you know, and somehow they got lost in them when they never received it. And so they thought I was trying to avoid being tested. I thought they were. So one of them was trying to. Yeah, because IRS will come to like the mail and all the IRS. Well, I just like if you have any questions, call the IRS. We're in good standing. We're buddies. See you, buddy. Here. Yeah, so the point is, those tricky questions, whatever is the call something, you'll call it. See the number? That's like, really right.
No, but I did the video. No. No, I don't know. I think you mentioned something about it.
The accent, the Indian accent, and all that is probably less than, I just said there were out of IRS and a lost. Yeah, it was reporting. So I missed the call because I was Tuesday night, the message, and then yesterday, same phone call, I answered it, and it was the message, it wasn't a lot of questions. But they said, I this is for you. I'm like, I do, but how do I know you found the right you? I was just making sure. So I think so I also made it on
Yeah, that's all saying. The IRS, you are in trouble. I'm not sure. Unfortunately, because I listen to a lot of talk radio, so we hear the same 3 days song.
So I can do this all from our catalog. None of those first steps.
They know where you live. Oh, yeah. They know where you live.
Yeah, but I don't remember how he formatted it on, you know. I can show you this.
Oh, okay.
Go into RGF. Go to your catalog.
Let's see this. This is the really. Okay. And I said, GHY, CIA, all those are actual government institutions. IRS is private things. That's the reason where. And you go to the IRS,
There should be something called
it's private response.
In Africa.
IRS, not you.
In
yeah.
IRS.
Don't let it open up a blank page.
Government bank.
Yes.
Private bank. No. No, I'm just realistic. That's exactly what it is. So, look it up.
Oh, no, I don't believe it, like you said.
Oh, man, look at what you did.
That's what I like to do. No. In that same window, over on the right-hand side. Yeah. So in there, there's a thing called database connections.
Okay, see, I said, that's really good feedback. I think that's.
You need to open it. So you can get all of the.
I think somebody has stated. I don't think there's just some John Wilkes group version 2.0 decided to run it.
How do you open it? You export it? I just clicked on it.
Could be more, like personally, I think use the basis for all the accounts. And whoever didn't want to do that, so the only way to get positive is that was.
I don't know what that other memo that you guys literally are. Okay, I didn't do anything.
Like a senator has been for 30 years, he's more powerful.
The
People
Congress,
understand that. Senators have been for 8 years.
no, Congress, and then there's the whole idea of checks and balances. The Congress is the president, the Congress.
Maybe close our, oh, close our
Because
catalog.
anything that tries to get back, is right, says the president, yeah, Congress, come back and say, and
That's also why the Congress had a bunch of people, the presidents, and one person is Supreme Court GHY. And so, yeah, there's a lot more power than the Senate, and also more people that can offset that power. But yeah, I mean, senators are, oh my God. You don't talk about corruption, man.
You think you should attempt to.
Going to look at presidents, going to for justice. A lot of estimates go all the way up. But then the people like senators, man,
Feel like it's already.
there should be an 8-year limit. It should be like broader bird and be like KKK and Senate like that. So there should be an 8-year limit.
I agree.
I pulled neighborhoods, homicides, and subways. That's but I don't think we're gonna actually be using subways.
Because they do the same thing.
I also pulled streets that realized houses and same massive. And I know that we need them all for this one. Which ones? I didn't see anything about subways.
Let's be.
Probably in census blocks, not streets or subways.
Right over.
That even created census blocks. But let me look at the.
What? Yeah.
Yes, census blocks. I get it.
Yeah. I mean, yeah. You say you have a number. But honestly, but when you get there, you know what it's going to take. Sure. Yeah. Yeah. Well, he was smart. Yeah. Next door. Yeah. But if you want to, but like I said, it's not really that important. Next step is to go and get the processing power. Yeah. Later. You know, you use the exact same sample points that you got for the first. You know that, right? So the problem tell you that range stuff. Bigger. Yeah. I have good iron. Yeah, I think. Right. Yeah. October, what are you looking for, like, I would do down, 2010. Okay. Yeah.
More than streets.
Commercial property. Yeah, like I said, you really don't need to make it like all that. I don't want to like complicated for
An experience.
Okay.
Yeah.
I'm here. But you said this is my bottle?
Yeah, but I mean,
Right. The top is.
like, what you do, really know it's practical. Maybe we go, just because it says it's not good, so yeah, you don't, yeah. Like,
Well, at least it's.
guys. Not their teeth. Anyway, all I'm saying, you don't, okay, you really don't.
Figure out how to.
Figure out how much question.
No, before that, like before the first question. Where it says we need to modify the sequel statement. Currently in the new period. Okay, but you have to do more than that. I already did that, right? But obviously it can't go like sides. Well, but I want to count how many homicides there are, so I'm trying to sum by the column that has the number of victims. Right, because I have an attribute table, right, column that's has a victim, and it has how many people. So I figured I would get a sum of those.
I can see your face like.
I copied that.
Yeah.
And then, but I'm not counting the summing, because there are some where the number of victims is more than one.
In the lecture, you said change.
Yeah. That's it. The cool thing is you understand what you're doing. To a certain point, you understand.
So the issue is that it says about 1,000. No, yeah, it wasn't 5,000. And then you put it as a underscore. No. I put some A dot numbers of victims as homicides. So what I actually do, in my way of thinking, is change the column of number of victims, sums them up.
Yeah, it will be. I mean, we can do a change section if you want to, but that has to be nice. There's a whole other, like, georepresentation stuff, and like making sure all your images line up like real good and all that, and like that's just gonna take like more time than it has to have. So you can do like a relative blank, like a relative. So it's just, you can do like, just be like, oh yeah, well there's.
Maybe I should just leave it.
Do your guys' questions have 2 periods after graphs? That's why it's.
Yeah.
Okay. No volume. you guys got it ordered? Okay. Can I help? Maybe, I'm not really sure what to do about it. It says failed to connect to the specified server, but doesn't give me the fatal message. You want to get to the cannot connect to the database because the database client software failed to load. Show the database client software is installed correctly. That sounds like your computer is missing something that it needs in order to do this. Sounds like you're not working well with your computer. Oh, okay, you're not. I'm sure you can. Or on this one. Oh, okay. Yeah. I thought you meant you were gonna download whatever. Well, I'm not really sure what I need for it because I haven't worked with it, so I'm not sure like what's on this list. So I don't know. Right, like, why isn't it? It's probably whatever thing you want to see. Yeah. You're trying to figure out what program. Well, I also changed the intersect names in hopes that would change, in the hopes that would fix it. So I don't know if I should mute it or if I should change it back. Why not just try to change the minimal amounts? You know, like very small. I guess you know. Because sometimes when you change one thing, yeah. So I was wondering if it was else out. But it didn't fix my problem, so you're right. It's hard to change. What are actually files for every aspect of this? Yeah, that sounds fun. I don't know. That's a good question. I noticed they have different symbols, but I don't know if either of those symbols mean. No, I only have one. gives you a different below every story. So it says our below turn in the new query and turn in the answer to the line question. Your hint, your new query will replace ST length divided by 100 as length with something else that uses count and will replace the streets and homicides.
So he doesn't want us to take into account.
Guess not.
I feel like it should work the same way. Okay, not compelling words.
Woo! So it's ST count.
No, it's just count.
Oh, really? So no sum?
No, it's just count.
Oh.
Or whatever column, really, because you're just counting number of rows. You're not actually, it can be any column you want.
Interesting.
You could use geom or
Incident E.
but that's not taking into account cases where you have multiple victims in the same incident. So we're really just counting incidents, not counting how many people die. But at least this one runs.
Hey! That's nice. So you took out the divided by 1,000, that's like great.
Yes. You want to leave an as, but you want to make it as whatever name you want to call it.
As murder.
Right, because that's basically saying. Only reason you have 1,000 is 2 kilometers.
I love how you don't need the quotes over anything.
You do.
Oh.
Not in this case, but where you're doing like name equals, you need quotes. Yes.
It was a green Chelsea combo. It was.
I had almost all of it and it wasn't working, and then Maria had a stroke of genius and we fixed it.
How
When it works out.
That's when I'm allowed access to the program. I start to think about it. Basically copy and paste this one, and we're replacing, right, Kelsey, correct me if I'm wrong, we're just replacing streets with homicides, so this gs.public.nbc-homicides.
Yep.
And also, do we do this neighborhood one?
Yes.
Yeah, we do, because we're checking by neighborhood. So we're changing this, it says the hint, into new query will replace some blah, 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 as length with count parentheses. And you can put anything, number, victim, or anything else from the attribute table, because we're just counting.
Penny rows.
Yeah, so if you want to put this one, so you can like geom or whatever weapon. Like this, so number of victims is number of victims, but we're not counting that, we're counting like rows, so you can put like borough name or incident fee or whatever.
Can I see either what file is he put that under? The him.
Oh, it's
in
in
the
the
Word
version of the SQL and spatial database lab.
Oh, did he added
Oh,
it
maybe
in
it's a new
after?
one. Okay, well, just from the sum, wherever the sum is, you're gonna erase the sum. and put count instead. That's not wrong. And also, instead of STA, whatever, you can put in, what do you put in? Number. If I do what's insulting. That's murder, I put murder, but just write something. And we're naming it. This is like our murder per neighborhood or like victim per neighborhood.
Yeah, I think so.
So.
Oh, yes, so, right quick, I did it on